Okay, so 2.3 is going to be on your test, or on your quiz tomorrow, okay? And it is 2.1, 2.2, and 2.3. 2.1 is graphing linear equations, right? And then figuring out where the solution is, or they might not have a solution, or the solution might be infinite, correct? And then 2.2 was substitution and elimination, and I think we feel okay about that, yes? Did we feel okay from last night's homework on that? Yeah. Okay. We like doing that type of thing. And then tonight is back to graphing linear systems and there we go. Back to graphing equations of lines, okay? 3.2. I'm just crazy. And 3.3, right? Yeah. Okay, so graphing systems of linear inequalities. Inequalities. Remember, when there are inequalities, you have to shade when you graph something, okay? You have to check and shade. So what you're going to do on your homework tonight, I suggest using two colors, a pencil and a pen, or two different pens, or whatever. But once you graph them, you're going to shade them, and then you should have overlapping shading areas, yes? So that you can see. So last time we did inequalities, we did linear inequalities with absolute value inequalities. Now we're just doing two sets of linear inequalities. Okay, so you're just graphing two lines. Okay, how do we graph lines in the first place? You have to get it into what form? Y equals mx plus b. Okay, if I divide by a negative on linear inequalities, what happens to the inequality? It flips. We missed that on our last test, some of us did, okay? So don't forget that. If my linear inequalities, when I graph them, if they shade in two opposite directions, what type of lines are they? Parallel, okay? Or I could just graph them on top of each other, right? I think there is one absolute value one in these examples, but this shouldn't be anything different than what we've already done. Okay. So let's graph these. These ones are already in y equals, correct? So let's graph this first one. We're going to make it green. Where do I start to graph that first one? Negative 5. 1, 2, 3, 4, 5 on the y-axis. What's my slope? Down 2 over 1. I'm going to actually reverse it and go up 2 and over 1 this way so that I can work with it. Up 2 and over 1 this way. It's the same thing. If I go down 1, 2, and over 1 this way, still falling the same way, okay? Dashed or solid line? Dashed. What tells me that it's dashed? The sign. Beautiful. It's just greater than. Now what do I need to do? Plug in a point. What point do you want to plug in? 0, 0. Okay, let's plug in 0, 0. 0 is greater than negative 2 times 0 minus 5. Is 0 greater than negative 5? Yes, so I shade where 0, 0 is, which is this way. Okay? Now, let's go over here to this one. Y is less than or equal to x plus 3. Yeah? Okay, where do I start my graph? Positive 3 on the y-axis. Some of you graphed it on the x-axis last time. Do not get that confused. Graph it on the y. And what's my slope? Up 1, over 1, up 1, over 1. Dotted or solid? Solid. Beautiful. Okay. Plug in a point. Can I plug 0, 0 in again? Yes. Okay, so 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? Yes, so I shade where 0, 0 is. Cool? That was pretty simple. We didn't have to rearrange anything. We can just graph it and do our nice little shading. Any questions on that so far? Okay, we have 4 more slides. Okay, what do I have to do with this top equation before I can graph it? Y equals mx plus b form. So if it is 2x, right, plus 3y, or yeah, is less than 6, what do I need to do first? Move the x to the other side. Will I get fractions in this one? Probably. Is that okay? Yes. 3y is less than negative 2x plus 6, yes? Now what do? Divide by 3, beautiful. And you get y is less than negative 2/3 x, right? Plus 2. Okay. So that equation changes to y is less than negative 2/3 x plus 2. What do I need to do first? Yes, graph 2. 2 is at, right here, right? It is plus 2, right? I'm not crazy. Yes, 6 divided by 3 is 2. And what am I doing with my slope? Down 2 over 3. Down 2 over 3. That's why there's a dot there. And down 2 over 3. Dotted or solid? Dotted. Remember, yours will be prettier. You have. Plug in 0, 0. So 0 is less than negative 2/3 times 0 plus 2. Is 0 less than 2? Yes. So shade down. Then you shade opposite, wherever 0, 0 isn't. Okay. Now, this one's already in y equals form, right? What's my y-intercept? 4. 1, 2, 3, 4. Okay. And my slope is what? Down 2 over 3. What did you say, Kaden? They're parallel. How do you know that they're parallel? So, if that's true, is this dotted or solid line? Solid. And if they are parallel because they have the same slope, what way is this one automatically, pretend this is perfect because I'm not doing well. What way is it automatically going to shade then? Opposite, because will parallel lines ever intersect or have overlap? No. So if I plug in 0, 0 to this, I plug in 0 is greater than or equal to negative 2/3 times 0 plus 4. Is 0 greater than or equal to 4? No, which in that case is opposite of where 0, 0 is, so you shade this way. But because they're parallel, I should automatically know that they're getting shaded in opposite directions. Okay? So if you notice that they have the same slope and that they're parallel, just graph the lines and then shade opposite. You don't even have to plug something in. Okay? Okay, this one has an absolute value with it, so we're going to graph one linear function and one absolute value. Now, a lot of people on the last test struggled to graph something that was just y is less than or equal to 3 or x is equal to something. So if you have y is equal to something, what type of line do you have? A horizontal line. Horizontal line through that point, okay? If you have x is equal to something, you have a vertical line through that point. So right now it says y is less than or equal to 3. So where do I need to go? Yeah, I'm just going to go to 3 right here. And do I have a dotted or solid line? Solid. And I'm just going to go like this. Now, because there's only a y to plug into, means I do not plug in 0, 0. I only plug a point into y. If I plug 0 into y, is 0 less than or equal to 3? Yes. So I'm going to shade down where 0 is. I like scribbling across that. Now, over here, absolute value. What do you have to graph first in absolute value always? The vertex. How do you know what the vertex is? It's not 4, 0, it's negative 4 and then 0. Okay, 0 because there's nothing on the outside being added or subtracted. And remember, whatever's inside with the x is opposite of what it is. So your vertex on this is negative 4, 0. Yes? 1, 2, 3, 4. So it goes right there. How do you plot your next point? What do you have to do to plot the rest of your V? You have to put something, yeah, you have to plug something in. If this is already at 0, I'm going to just plug in a 1 because it's next to it. okay? Plug a 1 into x. Y is greater than the absolute value of 1 plus 4. What is the absolute value of 1 plus 4? 5. So the point I'm going to graph is 1, 5. So here's 1, 1, 2, 3, 4, 5. What do I have to do with that point? Mirror it over to the other side. Dotted or solid lines? Dotted. Now, you're either going to shade on the inside of this, or you're going to shade all the way on the outside of this. I can plug 0, 0 in because there's nothing going through there, okay? So I'm going to do that. I'm going to say 0 is greater than the absolute value of 0 plus 4. Is 0 greater than 4? No. So 0 is on the inside, so I am not shading the inside because that is a false statement. I am shading out around it. Okay? And that's how we would graph one that's linear and got an absolute value, which we did last chapter. Okay? We did all of this last chapter as well. This is the exact same thing. We have one more example, and it is a word problem, and then we are done. And you are graphing linear inequalities and absolute value inequalities just like you did last chapter. So more practice for you. Okay. A discount shoe store is having a sale as described in the advertisement shown. So see that advertisement, it says Dan's Discount Shoes save 10 to 60% on all footwear, regular price $20 to $80. Okay. Use the information in the ad to write a system of inequalities for the regular footwear prices and the possible sale prices. So first we need to write inequalities. Okay. How many inequalities do you think we're going to have? Not 2. Kind of a tricky question. Okay. So why would you say 2? Oh, tell me what you're thinking. Because we're going to work from there. Okay, because it gives you a percentage and it gives you a cost, yes? Okay, so yes, we're going to have 2, but that percentage is a range, correct? And that cost is also a range, so we need 4. Because I need it to show how low I can go, how high I can go in percentage, how low in money, and how high in money I can go. Does that make sense?
So 2 per 3.
Yes, so 2 per thing, okay? Now, if we decide, we're gonna make one our X and one our Y. If I were you, I would make your money your X and have it go horizontally, like on the horizontal axis, and I'd make your percentage your Y, okay? Because percentage changes more, right? Like, it's dependent on what the price is, how much you get out, okay? So, dependent and independent. So, let's start with our X. We need 2 X inequalities. So, what could I say for inequalities? And it's going to be very basic inequalities. Like, it's going to say X is greater than or equal to something and X is less than or equal to something. What is the lowest I could go on X? No. Your X is your money.
Oh,
$20. So X is either greater than or equal to. Also, X is either what? Less than or equal to $80. Now, try it for percentage. Let Y represent it. Y is greater than or equal to what? 10. And Y is what? Now I have 4 inequalities. These are like simple inequalities, but we overthink this. Does that make sense? Okay? So now I have 4 inequalities. Okay? Then it says possible sale prices. So we add the system of inequalities for the regular footwear prices and the possible sale prices. That's why I went ahead and did X as the money because it lists it first as regular footwear prices and then the next is the discount prices. Now, graph the system of inequalities. How do I graph all of these? What do I have to do? How many total graphs am I going to have? 4, right? Just 4 lines, okay? So let's do it this way. Let's count by, let's just make this like this. count by tens here. Which takes me exactly to 80, yes. And then we're gonna count by, let's see here. I'll just make this a little bit bigger, we'll put that here. We count by tens here, to work to 10, 20, 30, 40, 50. I need one more. 60, okay. Now, let me graph this one in green. Okay, where do I go to graph that? 20 on the x-axis, right? And I make a straight line up and down, correct? And it is solid. Now, it says greater than or equal to 20, so do I shade to the left or to the right? To the right, it has to be greater than or equal to 20, I shade to this side. Good. Now, let's make this next one red, okay? Where do I start at? 80, and do I shade to the left or to the right? To the left. Right, it goes all the way through here, I guess. Okay? Now, let's make this next one blue. Where do I start at? 10 on the y-axis, and it's gonna be a solid line this way, correct? Okay. Do I shade up or down? Up. Okay. And then let's make this one black. Where do I start? 60. And I have a solid line like this, correct? And do I shade up or down? Down. Okay. So this hot mess shows me that everything graphs between these segments, correct? Okay. Now, it wants to know, use the graph to estimate the range of possible sale prices for footwear that is regularly priced at $70. So if I go to 70, okay, here's it, where it's usually at, okay? Where is it regularly, if it's regularly priced 70, what would be the sale price for that? What would you think would be approximately the sale price? Here's how we can do that, okay? We have to look at a range in between there. So if we come from here, you gotta think outside the box. If I come from $0 and come and make this, and I come out here and make this, 70 should fall in a range someplace here. Like from here, right? So it would go like that. So it would be someplace under here, right? So my money would be a range for $70, okay? It would be someplace around, it would be someplace like from $28-ish or $25-ish up to $65-ish, because you're gonna have a sale of at least 20%, right? Okay, and 20% off of 70 is 14, right? 10% of 70 is what? 7, so 20% is 14.
14.
Okay, I use the rule of tens when I do percentages, it's much easier. Just find 10% and then multiply by that number. So 14 from 70 would be what? What's 70 minus 14? 60, 56, 56-ish dollars. And what's 80% of 70 would be 56. So what's 70 minus $56? 14. Yep. So you have a range of money from there. Okay. That is what we're looking at. The word problem, there won't be any word problems on your quiz tomorrow, I don't think. But there are graphing inequalities like that. Yay.